Hey guys, great job on your projects. Really well done. We are gonna start projectile motion. We are gonna look kind of at the math behind it a little bit. Project Lead the Way does a whole little section on the math behind it, but we're also gonna do a digital simulation of it and maybe make a little slideshow to show your learning, do some of the practice problems. And depending on how long this online learning goes or how much time we have, we might make some small miniature projectile motion setups. Shout out to the students who made large scale ones for their choice project. They looked really awesome. So let's go ahead and get started. Today we're just gonna look at some definitions and kind of some general things. A lot of this you guys learned perhaps in physics. It's been a while for some of you. I'm not sure if they do it in honors and regular or how that, how long it's been for some of you guys. So we're gonna go through this. Okay, projectile motion, here we go. Couple things. Speed is just distance per time, meters per second, something like that. But velocity is speed and direction. So velocity is a vector. So with the negative or the positive, if we're looking at 2D or two-dimensional up and down sort of thing. And then acceleration is change in velocity over time, so meters per second squared or something like that. Gravity, the definition of it, it tends to pull objects towards the center of the earth or whatever other being, maybe the sun. But the acceleration is kind of that constant that we use. So that negative 9.8 meters per second squared falling down towards the earth, or negative 32 feet per second squared. So kind of if you're jumping out of a plane, you first start, and after the first second, you're going a speed of 38 feet per second or 9.8 meters per second. And then you start going faster and faster, 64, 96, 128. That's why if you drop something really from a high location, it can get going really fast by the time it hits the earth. That's one example of gravity. Another is what's more daring than skydiving? Dun, 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 the human cannonball, or shooting a marble out of a miniature launcher, or a pen out of with a rubber band, something like that. But a projectile is what we're looking at. It's any moving object, and then gravity is the force acting on it. So gravity pulls it towards the earth. So couple vocab pieces. We're going to look at the angle. You can use, it says here measured in degrees. You can use radians if you are comfortable with that. And it's the angle which the projectile leaves the cannon, and then the velocity, the initial velocity is basically the speed at the start. So if it was a 90-degree angle or pi over 2 for theta, the person would just go up, pause in midair for a second, and then go down. Oh, here's the down version. But most likely, they are not just going straight up to the earth. This is saying you'd hit the bullseye if it weren't for gravity, but realistically, you're gonna go downward like that. So there are ways we can figure out what the initial velocity is if we shoot this marble or person. If we know that distance, if we know gravity, and if we know that angle, we can calculate the velocity. Firing angle, x is the horizontal distance, g is gravity, v is initial velocity. They don't have mass in there. That is because this is my second grade science fair project. Basically, if you have a ball that's heavier versus a ball that's lighter, they're gonna feel gravity the same way. They're gonna land at the same time. I stood on a deck and I dropped two different things. One was heavier, one was lighter, and they landed on the ground at the same time. So just to get a little math in there, if we have this equation, the initial velocity is equal to the square root of negative gravity, or the velocity with that, times x, and then sine 2 theta. Oops. I think when they do this formula, they have the g as negative already so that the whole thing can become positive when you take the square root. So pause the video right here. See if you can solve for x. Okay, so thank you guys for trying that. Here is how you would do that. So quick, you would square both sides. That would give you this. Multiply both sides by sine 2 theta. And I apologize if I'm showing too many steps. I just don't really know over video what you guys have and don't have. So sine 2 theta times the initial velocity squared equals negative g times x. Divide both sides by negative g. And x is equal to the initial velocity squared times sine of 2 theta, which is the firing angle, divided by negative g. And that will give us this formula right here. So I don't really like memorizing more than one formula. I just like to rearrange, but if you want to have a whole separate formula like they do here, you can. So that is x, the horizontal distance traveled in terms of everything else. Okay, so I have a decent amount of you guys in AP Calc or Slash, so I'm going to throw this in there. I apologize for those of you who are not in there right now. But I want you guys to see if you guys can figure out why a firing angle of pi over 2 or 45 degrees produces the maximum horizontal distance traveled. So basically, I'm looking for you to set x prime equal to 0, find the max, basically of the function x. So go ahead and try that now. Pause your video and see what you can do. Those students. If you're not in one of those classes, I don't expect you to understand this part, but I just wanted to show it anyway. Okay, thank you guys for trying that. I'm gonna show you what I got. So if this is my function for x, sine 2 theta, then I'm gonna take the derivative to, in terms of theta, in order to maximize this function. So the velocity and the gravity, I'm going to consider constants when they fired that. So I'm just going to rewrite this as a constant times sine 2 theta. Oops. As x is a constant times sine 2 theta. Then when I take the derivative, I'm going to have constant times sine 2, cosine 2 theta times 2. So I just took the derivative there with chain rule. Then I have 2c times cosine 2 theta, or basically another constant, c1, c2, something like that. I'm going to set my derivative equal to 0 to find the max or the min. And basically divide both sides by 2c to get rid of the constant. So 0 is cosine 2 theta. So if I want to figure out what theta is, I'm basically saying the angle arc cos of 0 is equal to 2 theta. Now we have a lot of places where that's true, kind of on your unit circle. So for example, pi over 2, 3 pi over 2, we could go negative, we could go above 2 pi. I'm just going to look between 0 and pi over 2, or 0 and 90 degrees, because if you're realistically firing off that cannon, it's really only going to be an angle between 0 and 90, or 0 and pi over 2. Otherwise, it's just going to be like in this direction. So I'm just going to look for this problem between 0 and pi over 2, or 0 and 90 degrees. So the only spot where that is true is actually at, oh, I apologize. I'm looking for my final answer is going to be between 0 and 90. So I could look, in bigger locations before I get down to the final theta, because I'm going to have to divide by 2. So it'll be pi over 2 and 3 pi over 2, and it would keep going. So that's equal to 2 pi theta. Divide both sides by 2, and I'm going to have pi over 4, 3 pi over 4, etc. And this is the only one in that 0 to pi over 2 kind of range that I'm looking at. So pi over 4, or 45 degrees, is where you are going to, oops, I wrote that wrong, sorry. I meant 45 degrees. That's pi over 4. My apologies. So pi over 4 is that maximum angle. You can double check that it's a max by saying pi over 4 is here. You could check, for example, pi over 8. You do cosine of 2 pi over 8, or cosine of pi over 4, which gives you square root of 2 over 2. You could try something here. Cosine of 2 times 3 pi over 8, which is 6 pi over 8, or 3 pi over 4 gives you negative square root of 2 over 2. So you can see the slope changes from positive to negative, making that a maximum. So pi over 4, or 45 degrees, is the angle that will produce the maximum horizontal distance traveled. Sorry I wrote that wrong there the first time. I wrote 45 degrees. My geometry has gotten me out of my radian mode for a while. So pi over 4, I did it again. Or 45 degrees is the angle that will have the maximum horizontal distance traveled. So a little bit of calc in real life for you guys. Everybody else, thanks for bearing with me. Just wanted you guys to kind of see that. Let's look again. Here's our original equation. Let's see if we can just solve for theta. So if we are trying to find the angle, so we have the initial velocity is equal to the square root of this. And again, we will square both sides. Oops, I should let you guys try first. See what you get. Okay, thanks guys for trying. Let's pick up where we left off. We had squared both sides, and we have this. Multiply both sides by sine 2 theta. Cancel that. We have sine 2 theta times initial velocity squared equals this. Divide both sides by initial velocity squared. And we have sine 2 theta equals initial velocity squared on the bottom, negative gx on top. And then this is where some people get stuck. In order to, quote, undo sine, unquote, basically you're taking the arc sine or the inverse sine. So you would say sine to the negative 1 of all of this equals 2 theta, and then you can just divide by 2. So theta is 1/2 arc sine or inverse sine of that. So that is how they get this next formula. They got a little lazy and didn't divide by 2. But if you want to find the angle, you can use this formula. So that is all of our notes for today. We will have some vocab stuff coming up, as well as some practice problems, some online simulation, and then hopefully we'll have time to do a mini project. We'll see on that. But thank you for listening. Thank you for looking into some of the calculus stuff so you could see an application there. And have a great day. See you guys. Bye.